this class we are going to see about DC drives and its applications. So first of all, what is DC drives? Okay, first drive and then DC will see. Drive is nothing but a group of mechanism or a group of components are connected together and used for a particular motion control or movement control. So this is a DC drive. So first we will see about the basic block diagram of a DC drive or a electrical drive. First there will be one source, then there will be one power modulator. Next, from the power modulator we will be connecting a motor, and from motor we will be connecting one load. Okay. From the motor we will be using the sensing unit, and from sensing unit we will be connecting one control unit. Okay. This is the basic block diagram function of the DC drive or electrical drive control system. So first of all, the motor. So how we can select a motor is nothing but from the load. What kind of load you are using? So based upon that load, you will be selecting a motor. So we will see the basic block diagram here. First, the source. The source that can be either AC source or DC source. Okay. Here, AC source will be of the single phase supply or three phase supply. As we all know, for DC there is only plus and minus terminals. Since our topic is of the DC drives and applications, we will be see about the focusing on the DC. So the DC source, that may be a battery or a heavy battery that can operate a function of even a 1 HP motor or half HP motor. So first, this is the main source we have seen, and from source the power modulator is connected. The power modulator has the major converters like AC to AC, DC to AC, as well as AC to DC, and again DC to DC. So all these functions happen in the power modulator. The AC to AC, we already know that is, you can say that is a rectifier, and DC to AC is about inverter. This is a rectifier, and this one we can say as a converter, and this one we say as a chopper. Fixed DC into variable DC. Here the fixed AC into variable AC, even the frequency changes can use a cycloconverter. So all these functions are happening in the power modulator. So next, we are coming into the very important area, that is the motor and the load. Okay. Here motor, as we also know, already we studied the basic electrical machines. That is, motor can be classified into DC motor as well as AC motor. You all know DC motor can be broadly classified: DC shunt motor, DC series motor, and DC compound motor. Whereas in AC motor, we know induction motor is the major. Under induction we use one or squirrel gauge induction motors, or even in some case in DC we use permanent magnet. Is a special electrical machines motor. Okay. This load, so this is the load is a very important term in case of DC drive. So if this is a DC load can be, and even the AC load, the loads also can be differentiated. So And what is the use of sensing unit is here, the motor, it can be used to sense the motor's speed and even torque, or even all the ratings, everything can be sensed by use of sensing unit. So if there is any problem occurs or sensed by the sensing unit, and it will be sent to the control unit, and control unit will be controlling the motor. It's like a closed loop control system or closed loop system. So if there is any problem in motor or load, automatically the control unit senses it or find it the fault and rectify till our goal is achieved. This is a basic functional and block diagram what we have seen. Then next we will go for as our topic is DC drives and its applications. So application. What is application? So what the application is nothing but what in day-to-day life we are using for our particular uses. So we can say we can take this basic three: shunt motor, series motor and compound motor here. So shunt motor. So we will see, if you take a speed versus so these are basic mechanical characteristics of the shunt motor. So where here the shunt motor is also called as the constant speed motor. So just analyze it. Where does this shunt motor can be used in the industry? So for example, we can take a lathe industry. The lathe machines will be running for from if you start from the morning until afternoon or evening. So there is some heavy huge time gap where it will be functioning for a long period of time. So for that particular purpose, so we need a constant speed. So that constant speed so I am writing here shunt motor. So constant speed motor we can use in lathes and even in drilling machines and cutting tools, etc. As we clear, DC shunt motor is used for lathe and cutting tools and drilling machines. So next we will see about the other motor, DC series motor. In fact, it is a very, very dangerous motor. So we will explain why the DC shunt motor's basic diagram. So you know A1, A2, plus minus will be IA, SH, voltage plus minus 230 V DC supply. Okay, here we already know that the current is separated here, so there is no that much impact in the current in shunt motor. So that's why we say that it is a constant speed motor. And if we see about the DC series motor, so as we all know, so here all the currents are same. IH is equal to ISC is equal to IL. So since there is a copper thick wire winding with a in this DC series motor, the current flow will be very high. So for that case, so we will see the mechanical characteristics of a DC series motor. take speed and okay. Without load, DC series motor should not start. So why? Because the motor winding is directly connected with the armature and also it is a thick copper wire. So the flow of current will be heavy. So in this condition, without a load, we should not connect a DC series motor. So you can see the applications of the DC series motor. The DC series motors can be used in a very high speed or high torque at the initial stage. So for this DC series motor, we can use in the applications where cranes and lifts, hoists, even the electric trains, electric train or electric traction purpose, where you need a very quick starting. So then only the function will be accomplished. So that's why we are using the DC series motor for these applications, the cranes, you can see lifts and hoists, electric traction. So immediately the train has to start. So for that purpose, the heavy current should be needed. So for that purpose, they are using DC series motor for this electric traction applications. So next we will see about the DC compound motor. Okay. So DC compound motor is nothing but the combination of both DC shunt and DC series motors is the DC compound motor. So ESC and ISH, IA current and RA. So this is the connection diagram of the DC compound motor. So as we all know, since a compound motor is a combination of both the series and shunt motors. So this compound motors, particularly where it is using in we can say printing presses and steel mills and even the cutting machine tools, glass cutting. So where here we can use the compound motor, but most probably the compound motor is not preferable for the industrial applications mostly. So that's why we are going for the shunt motor as well as series motors. Even the permanent magnet PM DC motors, that is the permanent magnet DC motors, can be used for low power applications, and if you can say even the robot sensing or robot arm. So these are applications of the PMDC, robotic arm principles. Whereas if we go for our next, we will see about the AC machines. Since our topic is the DC drives and its applications, you should know basically the shunt motor, series motor, compound motor, where in which industry they are using this type of motors. That's our main motto or main topic to be discussed today. And this PMDC I have already explained to you, and this induction motor. So these also play a vital role in the three-phase industry. We can say heavy industry. We know in industries they are using three-phase AC supply, Okay. So most probably the squirrel cage or the wound rotor can be used, for example, in the rolling mills, even the robotics also. The heavy industries use induction motor as the main motor here. We already told, based upon the load we are using a motor. If we are using a heavy load, so definitely we should use a DC series motor here to lift it up or to traction it up. And even in AC machine there is linear motors also, linear induction motor. So linear induction motor is nothing but, so it will be, the core will be in linear position. This is used for electric traction and magnetic levitation principles applications. So in this class we discussed about the basic block diagram and what are the power modulators and what are the motors and how we can select a motor based upon the load. We also discussed here. So now we will be discussing about the comparison of AC drive and DC drive. Both AC drives also have some applications, DC drive also have some applications. But we can see some comparison on AC drive and DC drive. As we all know, AC is readily available source. So as we know, single phase AC that we are using, and industry, residential single phase AC and industry 3-phase AC readily available. So most preferably these AC drives can be used, and in some extent like DC drive we need a separate rectifier panel there, since it is a DC power supply from AC to DC conversion. So this itself will take some cost, so high cost, and this AC drive is low cost. But for heavy load, this DC is preferable. So the AC is for mid-level applications or mid-power applications. So both have advantages and disadvantages. So in this topic, hopefully I have discussed some basic point about DC drives and applications. Hope you all enjoyed, and thank you for your patience.